carboxylic acid. You're going to get a racemic mixture. You guys remember what racemic means? So one coming out, one, this group will come out of the board or come into the board in a mix. And then you can do a substitution and replace this with whatever whatever you need. In this case, you need an amine group, right here. So the R group, the side chain, is going to be, you have to have a carboxylic acid that has the side chain that makes that amino acid specific. And we tack on a bromine and replace that with the amine group. So your precursor for, say, your precursor for alanine would just have a methyl group and a carboxylic acid. Or asparagine, you'd have this right here. You'd have the addition of carboxylic acid and the amine group both. This is where we're tacking on the halogen and then replacing it, substituting it with the amine group. And then another way is amidomalonate synthesis, okay? So we can take esters here, this is a diester, and we can treat it to tack on an R group here. And then we essentially remove those ethyl groups on either side and cut it in half. And then from there, well, this is the generic form, right? This is not making an amino acid. This is the reaction to take a diester and turn it into a carboxylic acid. So first, we take an ester, make it a carboxylic acid. That's halfway point, right? Amino acids have a carboxylic acid group. From that standpoint here, this is the diethyl malonate. We tack on the R group, the R group being our amine and our carboxylic acid. Okay. From there, we attach our side chain. That's what R is going to be, and then we reduce it. All right. So we have acid and heat to reduce the rest of that. Okay, it gives us just this part. So from an ester to a carboxylic acid with an amine group on it, then we put on the side chain, then we remove that malonate. And so, in this case, if we wanted to make phenylalanine, right? We would take our diethyl malonate group, and it has this, essentially this is the carboxylic acid, and now here we have the nitrogen attached directly to it, but we need it to get over to the alpha carbon. So you just pick essentially what you want your side chain to be, and you have a halogen on it. Okay? That halogen is going to come off, and you're going to attach it right here. And then, look what happens here. This ends up flipping to there, so that the nitro group, or the amine group, is no longer attached to the carbonyl carbon. And, right, at this point we don't have our hydroxyl group. guess I have a mechanism for the Straker synthesis. So how are we doing? We got 10 minutes. So let's try a problem. Tryptophan. So let's look up tryptophan. And depending on what that side group is, you got to figure out what your precursor is going to be. And all you do is take that side chain and put a halogen on there, put bromine on there, and that is what they're asking for. Okay. Tryptophan right here. So this is what you're going to want to use, this bicyclic compound with a bromine coming off of it. And then we use our diethyl malonate. So instead of having this right here, right, we're going to put this under that arrow. And that will do the substitution. Bromine gets replaced with the malonate. And then we reduce the malonate off of there, move this around, oxidize that end to get the carboxylic acid. And so here's some practice problems. Why don't you work on these sometime between now and Thursday. If you want, we can go over them at the beginning of class. Essentially, it's just the same thing. You're looking for the side chain, attach a bromine to it, and then work from there. The other way to do it, one of the other ways, is to use a nitrile. Okay? So we take an aldehyde and sodium cyanide and ammonium chloride, and we can attach a nitrile onto there. In the presence of an acid, we end up reducing that nitrile to a carboxylic acid group. Okay, we've already got this amine group on there, and it's on the appropriate carbon, and then we start with some precursor that has the R group on it that we want. Okay? So the aldehyde is going to have that side chain built into it already. It's different from the ethyl malonate where we pick our side chain and halogenate it. Here we pick an aldehyde that already has the side chain attached to it. All right, so if we're going to make alanine, we would pick an aldehyde that has a methyl group on it. Or is that formaldehyde? No, it's acetaldehyde, right? And go through that process. Right? And here's the mechanism. So initially, we're going to attach our amine group on, and then we're going to reduce that by ripping off a hydrogen here to make NH2. Right? In addition, we're going to protonate that oxygen to get our carboxylic acid group. And then so we have our ammonium chloride. It's going to decompose into the acid and the ammonia. Right? That way, not super efficiently in equilibrium, but we could use Le Chatelier's principle to drive that further. And so the ammonia is going to attack here, be our nucleophile, and we've attached that on. Then this comes after that hydrochloric acid, protonates it, and then we do that, we do 2 rounds of that. Okay, so we have our amino group put on here, and then we're going to put that hydrogen, take the hydrogen off, put it through this hydrochloric acid again, and then a series of more steps to put on the nitrile. Okay. From that, we can then take the nitrile and reduce it to carboxylic acid. Okay. So similar here. And just going through that mechanism. All right. So a couple different ways. We can use halogens, we can use nitriles. Right? And there are some practice problems for that one too. So for the Strecker synthesis, what reagents will we need to make these? And then the next problem is we have these aldehydes, we convert them into the amino nitrile, so that's going to be this step right here in the mechanism, so the amino nitrile, and then we hydrolyze it, we get our amino acid. In each case, draw and name the amino acid that was produced. So again, acetaldehyde, that's going to just have that methyl group. So that's going to make where was it? Was it here? Yeah. That's going to make alanine. 3-methylbutanol, well, you have to draw that out and then go through the process, see what that side chain looks like, and then what's the amino acid that corresponds, and then methylpropanol. So let's work on those between, we only got a minute left, so let's work on those between now and Thursday, and we'll go over them first thing on Thursday. All right? Okay. In the meantime, be thinking about PCR.